All right, welcome back. We're going to start by doing, I guess, a long form regression, for lack of a better term. When you come to the data tab, you'll see there's some data analysis stuff on mine. If you don't have that, go to the File button, click on the options, click on add-ins, click on Excel add-ins, just hit go, and check all 4 of these boxes and click OK. And that'll bring it in. So we're going to go to data analysis, and then what we want to do is run a regression. So we're going to click on that. All right, our y is our dependent variable, so that's the log of charges. So I'm going to click here for my selection, click on the first charge, do a Control-Shift down arrow key, and then a return. And then our x's are what we're using to explain it. So I'm going to go ahead and click on my x's and come up here to the top. And then we're going to do age, female, length of stay, do a Control-Shift down arrow key to highlight them all, and go ahead and click return. Click on the labels function so to let it know that the labels are in the top row. And at that point, we're going to output to a new worksheet, and it's going to be called, let's just call it temp. All right. So Excel has gone and performed the regression for us, and we're just going to go ahead and interpret or look at some of these values. So the first one that's important is the R squared. So the R squared represents the amount of the variance that we've actually explained. So the higher the R squared, if you get a 1 for R squared, it means you're deterministic. You've explained everything. You want higher R squares are usually better. The second thing is the standard error, the estimate. So what a regression does is it says this is what the expected value is going to be. And the standard error says this is what the distribution, the variance is, or the standard deviation of our estimate. So we're going to use this variable in trying to determine what the main, or where an outlier is and where an outlier isn't. And then we have an ANOVA analysis, or regression has 3 variables, so we lose 3 degrees of freedom associated with it. Our SS sum of squares. Anyway, next thing down here, this is the coefficient. So the intercept is 7.44. That would be the kind of the average. The coefficient on age is positive, which means if you're female, you tend to have, it's positive, so the older you are, the more expensive your stuff tends to be. The coefficient on sex is negative, meaning if you're female, your charges are tending to be less. And the coefficient on length of stay, as we would expect, is positive. The longer you stay, the more more expensive it's going to be. All right, and then we have the standard error estimate. So if we take this number and divide it by this number, it gives us our t-stat. And then our t-stat is used to calculate what the underlying p-value is. So how likely is this value equal to 0? And that's, all of these are highly significant in terms of the regression. So we're explaining 3% of what goes on, but our variables are actually important in terms of the explanation. Okay, so this is our generic regression. The problem with this is that all we get are numbers. So if our data changes anything, then we have to go and rerun this regression again. So I'm going to go ahead and delete. I'm just right-clicking there and go ahead and delete the tab. You'll get this warning. We'll just go ahead and delete it. You don't have to delete it. It's not going to get graded. There's nothing really there to grade. And we want to come over to our regs data. All right, so here what we're going to do is use a function called linest. And we're going to run through these two guys. The first one we're going to run a regression against just the raw values that have been Winsorized. And then the second one, we're going to run it against the log. And then the third one, we're going to include the code in our regression. So these are the 3 regressions that we're going to run. You're welcome to run some additional ones, but these ones are the ones that are going to get graded. So I'll come over here and go to a no fill, and then I'm going to hold down the control key and zoom in a little bit so things show up a little bit better. This really should be reg raw. Alright, so as an array function, we need to highlight the area that we want. So we're going to come over our length of stay, sex, age, and the intercept, and we're going to come down 2, 3, 4, 5. So this is how we're going to set it up. Now we're going to say it's equal to linest, and we need our known y, so we'll come over to our data, and what we want to do on this one is pick our Winsorized but not log transform variables. Now we're going to do a control shift down arrow to highlight everything. Then hit the comma. Alright, make sure you hit the comma before you do anything else. The next thing we need, as it says, is the known x's. So now we're going to come up to our age variable. I'm going to hold down the shift key and go over 3. Right, so now I'm going to hold down the control key, hit the down arrow button. So that highlights everything that we're interested in. Next is a comma, and then we want 1 because we do want a constant, comma, and 1 because we want the statistics associated with the regression. End it with a parenthesis, and then again, listen carefully, hold down the control, the shift, and the enter key. So this is now created our underlying regression. And again, this is against not the log, but against just the raw data. So we get length of stay having a coefficient of 182, sex having a negative coefficient of 447, age having a positive coefficient of 72, and the intercept of 1815. These are our standard errors, so if we wanted to know what the t-stat was, this is simply going to be equal to the coefficient divided by the standard error. So our t-stat's 4.47. Down here is our r squared, so in this case it's 5%. And then over here is the standard error of the estimate. So this is our standard deviation of our prediction. And then we have sum of squares and degrees of freedom down here. Alright, so that's our first regression that we're going to run. Now, econometrically, or from a regression standpoint, regressing dollars is always kind of a problem. There's sort of a deterministic aspect that goes on. You tend to get higher R squares, but less accurate models out of it. So the next regression that we're going to do is going to be based on the logarithmic transformation. So again, I'm just going to highlight and clear the fill, and it's equal to linest. We'll come back to our data tab, and in this one we want to go ahead and pick the log transformation, do a control shift down arrow to get those, then a comma. I'm going to go ahead and highlight my ages, do a control shift up arrow, take my finger off the control button, leave it on the shift button, and go down 1. So that's the highlight of my dependent variables, or my independent variables. Then 1, 1, end it with a parenthesis, and then do a control shift enter. So these are my new coefficients. This is exactly what I found in the first regression that I did. My R squared is, again, is decreased to 3.5%, but which is less than the 5, but econometrically the log transformation is going to create a better, more stable model. Alright, now I'm going to do the last one, and then we're going to go ahead and end the video. Again, I'm just going to clear this, and this is equal to linest. And then my known y's are going to again be my Control Shift down arrow key, my log transformations, then a comma, and then I'm going to go ahead and include in the estimate the medical code. Now I'm going to do a Control Shift up arrow key, take my finger off the control button and go down one for my highlight, comma 1, comma 1. So intercept and calculations, and then enter return. No, I'm sorry. Do a Control Shift Enter. So these are my new coefficients. All right, so it's interesting. You have to be careful from an econometric, from a regression standpoint. The codes may not necessarily correlate with the underlying costs. Now, in medical coding, they actually try and do that. When they pick a particular code, they try and pick it in such a way that the higher the code number, the higher the cost it's going to be. But that's not necessarily the case. And there's workarounds for that too. There's what's called recoding. We're not going to get into that, but it's another thing that can actually happen. All right, so this is the model that we're actually going to end up using. Our R squared is 21%, and our standard error estimate is 0.61. You can see how it's come down a little bit. So this is the function that we're going to use. Let me go ahead and end the video here. When we come back, we're going to apply the regression. A lot of students have problem understanding what it means to apply the model. So we're just going to do it, and hopefully that will help you understand what I mean. All right, thank you very much. Bye.